Hello and welcome to another WJEC A level physics question. This was from Unit 1 in January 2013 and was question 2, and it's basically a question about potential dividers, which you'll now find in Unit 2 work for WJEC physics. So first thing we're asked to do is to define resistance, and the resistance of a conductor is defined as the potential difference across a component. So we can put that down. Divided by the current through it. It's basically R equals V over I, but put into words rather than letters. We're told that the unit of resistance is the ohm, and we've got to show that it's possible to express the ohm as joules, seconds, coulombs to the -2. So let's start by looking at the units that we have for potential difference. So PD is the volt, but the volt is exactly the same as a joule per coulomb if you've learnt your definitions properly. And current has the units of amps, but amps, if we know the definition of current is the rate of flow of charge, is the number of coulombs per second. So if we put the two of them together, the unit for resistance will be the joule per coulomb divided by the coulomb per second. So looking at those, we can see that there's a J, there's also a seconds to the -1 on the bottom, which is the same as a second on the top of the equation, and C to the -1 divided by C is C to the -2, exactly as requested. The next part of the question gives us a potential divider and asks us to write down an equation for the current through resistors R1 and R2 when the input PdVin is applied as shown. So here we're just looking for the idea that current is V over R total, and the total resistance here is simply R1 plus R2. Next we've got to show that the output PD V out is given by the equation V out is R2 over R1 plus R2 times V in. And I'll just go back to the last part for a moment and just note that V is actually V in. So to find V out, all we're going to do is we're going to multiply the current times by the resistance where that output is connected. So it's I times R2. Now I, as we've just said, is V in over R1 plus R2. So times R2, and you'll see that this equation is just basically a rearrangement of the equation that we've got to prove. The next part of the question gives us two 40 ohm resistors and an 80 ohm resistor and asks us to draw a diagram showing how we can combine two of them to give a total resistance of 20 ohms. Well, 20 ohms is less than any of the individual resistances, and therefore we must be looking at a parallel combination. Remember that resistors in series always add up, and therefore the total resistance increases. Here we can also use a little trick that if we have identical resistors in parallel, the total resistance is equal to the resistance of one of them divided by however many there are. So in this case, if we take two 40 ohm resistors, then the total resistance will be 40 divided by 2, which is the 20 ohms that we need. And just making it clear in my diagram that this is a parallel arrangement by showing the current splitting. Next we're asked to use all three resistors and make a potential divider circuit for which V out compared to is 2.4 volts and V in is 12 volts. Well, the ratio of V in to V out is 12 to 2.4, and 12 to 2.4 is 5, so that basically means we're going to split the total resistance available up into 5 shares, and we want one of the shares to be worth just 1 if you like, and the other to be 4 of the shares. And the way that we can do that is to put the 80 ohm resistor at the top and then have our parallel combination that we just put together of the two 40s at the bottom, and then this will be V out. So these are the 40s and this is the 80. If you like, you can check that calculation using a formula from the previous page. V out will be R over R total. Well, the parallel combination we've just proven is a resistance of 20 ohms, and the total resistance is 100 ohms, 80 plus 20. That's that 1/5 that we mentioned over to the left of the input voltage of 12 volts, and that does indeed give us the 2.4 volts that we require. Thank you very much for listening. Please remember to like and subscribe.